Every time a language model finishes your sentence, a specific piece of math called a transformer is doing almost all the work. Before transformers, AI read text the way you might read a book with a very short memory, one word at a time, left to right, forgetting earlier words as it went. That made long sentences really hard to handle. In 2017, a team at Google published a paper called "Attention is All You Need." It introduced the transformer, and it changed almost everything about how AI processes language. The first thing a transformer does is break your text into tokens. A token is usually a word or a chunk of a word. The sentence "I like transformers" might become 3 tokens. Each token gets turned into a list of numbers called a word embedding. Think of it like giving every word a unique address in a giant mathematical space where similar words end up near each other. Now here is the part that makes transformers special. Attention. Instead of reading one word at a time, the model looks at every word in the sentence at once and asks, which other words should I pay attention to right now? For the word "it" in the sentence, "The dog chased the cat because it was scared," attention helps the model figure out that "it" probably refers to cat, not dog. That connection gets scored with a number. Those scores form what is called an attention matrix, a grid where every token scores its relationship with every other token. High scores mean strong connections. The model uses those scores to decide what context matters. A transformer does not just run attention once. It runs multiple versions of attention at the same time, each one looking for different kinds of relationships. Grammar, meaning, who did what to whom. After attention, each token passes through a small neural network called a feed-forward layer. This layer does extra processing on each token individually, adding more nuance to its meaning. One attention step plus one feed-forward layer equals one transformer block. A real language model stacks many of these blocks on top of each other, sometimes dozens of them. Each layer refines the meaning a little more. Early layers tend to pick up basic grammar. Deeper layers seem to handle more abstract ideas like tone, facts, and reasoning. Researchers are still studying exactly what each layer learns. At the very end, the model looks at the final set of numbers and predicts the most likely next token. That prediction is how it generates text, one token at a time. The reason transformers took over is speed. Because they look at all tokens at once instead of one by one, they can be trained on massive amounts of text using parallel computing, which made scaling up practical. Almost every major language model today, the ones powering chatbots, search, and translation, is built on this same core idea: tokens, embeddings, attention, and stacked layers. If you want to go deeper, the original attention paper is free to read online and surprisingly approachable. The math is worth a look if you are curious where all of this actually comes from.